In this lesson, we will talk about methods. Methods allow us to remove repetition in code and define reusable code. Methods are reusable modules that can be called repetitively to do some particular functionality. Using methods, in fact, is called modular software development. The structure of a method is as follows. We start with certain number of modifiers, a return value type of the method. This is the type of value that the method will return when called. The method name, a list of parameters encapsulated in parentheses, followed by a block which contains the statements of the method. Right? So let's take a concrete example. Here is a method definition to compute the max of two numbers. Here, the public and static are modifiers. Right? We won't get into what public and static mean. That will be covered more in object-oriented design lesson. But in a general sense, they control visibility and the behavior of the method. Then there is int, which is the type of value, data type of the value that is returned. Max is the name of the method. And then there are parameters. This is a list of typed values that are passed into the method, input that the method takes. Then this is followed by the body of the method. The body of the method essentially is comparing the two numbers and returning max of the two numbers. Now there is a return statement here which we'll talk about more in detail in a little bit. Right? So the new terms that we've learned are modifiers and parameters. An additional term that I would like you to know is called signature, method signature. Method signature is made up of two things. It's made up of the name of the method and the parameter list. Now the parameter list is an ordered list, ordered typed list of values that are passed in. Right? Note that a signature does not contain the return value. The signature only contains the name of the method and the list of parameters. Right? So moving on, the method can be called or invoked as follows, as shown in this example. The one we defined earlier, max, can be called passing in actual values for the parameters. These now are called arguments. In the definition, they are called parameters, but when you pass an actual value, the term we use are we passing in arguments. So here 2 and 3 are arguments that are passed in, and the max of the two is calculated and returned by this method, and here it is assigned to another variable. Okay, so let's try this out in code. Here I have typed in the method definition already, and then I have also an example of invoking it. So notice that now this class definition has two methods. First is the main method, and then there is the method that we have just defined. In the main method, the body has an invocation for max. Right? So if you call this, it's essentially comparing x with 356, and we should print the higher value, which is 356. So going back to this piece of code, let's talk about the return statement. So return is a new keyword that we have introduced, and this is followed by a variable or an expression that represents what the method is returning. Right? So in this case, it is returning an integer, which matches this type. Now, methods don't always have to return a value. You could define methods that return no value, in which case we use the keyword void to represent that no value is returned. So here's an example of a method called printName that all it does, it prints a string, and it's not returning anything. So we are using the keyword void. Now, there is an implicit return at the end of this body, but you could also put it explicitly. You could just use a return statement with nothing followed by a semicolon if you wanted to return somewhere in the middle of the code. Now let's take a deeper look at how parameters and arguments are handled with method invocations. So arguments are typically passed by value. What that means is a copy of the data is passed in. So if you modify that data within the method, it is not reflected outside. So let's take a concrete example. Here I have a class with two methods. One of them is main, the other one is a new method I've defined called increment. This method takes an integer as our parameter and increments it inside, auto increments inside, and prints the value. In main, I have declared a variable. I print the variable, call increment with that variable, and then I print it outside. The question is, what happens when I have called increment? Increment has modified the data inside, and now I'm trying to print it outside. What happens? And in fact, as I've said, a copy of the data is passed in, so any changes you make are only valid within the body of the method and would not be reflected outside. So if you run this, you will actually see that it prints 1 followed by a 2, which is a value within increment, and then a 1 outside. So we can actually try this out. Let's copy the two methods, and we can overwrite our existing code here and then run it. You'll see exactly what we expected. Next, we'll talk about a concept called overloading. Now, overloading allows us to use the same method name for different methods, right? Now, how can you do this? Now, you can only do this if the signature is kept different for the various methods that you have defined. Now, recall, a signature is made up of the method name and the list of parameters. So either the method name has to be different or the list of parameters have to be different for the signature to be different, right? So let's take an example. Now here, I have overloaded the definition max in 3 different ways, right? In the first one, I have our original definition, which takes 2 integers. In the second one, it takes 2 doubles. And in the third one, it takes 3 doubles. Now, these are all valid to coexist together. And the compiler will figure out, based on the signature, which one to use, right? And typically, this works pretty well. But there are cases where this could get confusing, where the compiler is not able to figure out which one to use. And this is called ambiguous invocation, because the compiler cannot figure out which of the methods it should really be using, right? So let's take an example and see how this could cause some confusion. So if you look at this code here, I have 2 definitions of max, but they both return type double. One takes an integer followed by a double, the other one takes a double followed by an integer. Now, if you call max with 1 and 2, the compiler cannot figure out which one matches, which signature matches this one, and you will get a compilation error for this. And we can actually try this out. So let's copy this code and go to IntelliJ. And we will overwrite this. And here we will just do something simple. And let's see what happens. And you will notice you get the reference to max is ambiguous because the compiler cannot figure this out. Now let's talk about something called scope, or scope of variables. Scope is part of the program where a variable has value, right? So let's explore this with a concrete example. So here I have a definition of a method. The method is taking in a parameter, an integer value I. There's a statement followed by another declaration of a variable called j. There's another statement, and then there is a for loop with a body, right? So let's take the variable I. Now I has scope or has meaning through the whole body. It can be used. However, j, which is only declared here, only has scope starting S2 to the end, right? It cannot be used earlier than that because it wasn't declared. The variable k, the counter variable or the loop variable, only has scope within the body of the for loop, right? Now, there's one term that's used when you might hear somebody say, oh, that's a local variable. And when you say a local variable, it typically refers to a variable that has scope within a method. It is not visible to other methods or within main or outside it. Okay. Now, we have covered several interesting things in this lesson. We talked about method definitions and method invocation, returning typed values or returning void. We talked about values that are passed in as parameter. They're typically passed as a value. That means a copy of the data is passed. The concept of overloading, where you can have several methods with the same name. The problems that it creates with ambiguous invocation, where a compiler cannot figure out which method should use, and the concept of scope. All right. Thank you very much.